Hey everybody, I hope this video finds you well. In this video, we're going to be continuing with the topic that we introduced in the previous one, which was introducing you guys to conditional analysis through the use of the conditional distribution. Remember, the general idea here is to be attempting to study the relationship between two categorical variables. To sort of help with that, we're going to do a quick sort of computational example running through taking a look at some data that is presented in like a two-way table, working through some different questions related to that, and ultimately using and sort of building the conditional distribution. So what we have here is we've got that we're going to suppose that you work for a drug company that is working on a new pain reliever that they call Cheapo Comfort. So that's going to be their new pain reliever that they're experimenting with. So they conduct an experiment where a large group of participants who are suffering pain symptoms are randomly assigned to take either this new drug, this Cheapo Comfort, standard aspirin, or a placebo. From way back in our class, you would know that this is what we would call as a completely randomized experiment, right? The people come in and then are immediately randomly assigned to one of three treatment groups here: Cheapo Comfort, standard aspirin, or placebo. Then, after they take this drug, after a few hours, they're asked if the treatment that they took removed their pain, which of course would be the best outcome, reduced their pain, which is a good thing, but maybe not the best, or did nothing at all, which of course is not what we're looking for here. And so you get this data. So this right here is presented as a two-way table. We see this is the choice of sort of treatment that they got: Cheapo Comfort, aspirin, or placebo. And then this is the effect that they felt: removed, reduced, or did nothing. So as we know, what we're going to be doing with this is just answering some basic questions. We'll see we've got talking about the sample size, calculating a few percentages, then we'll construct the conditional distribution, and then in E and F we will actually use the conditional distribution in a couple different ways here. So again, I would recommend, if you feel pretty comfortable with this topic, you might want to try these pieces first and then watch the remainder of this video, or you can just follow along immediately and sort of follow the example as we do it here. So we will do this on the next page, though, so that we have a little bit more room to sort of work here. So let's go ahead and do that. So there's our two-way table, as we discussed in the last video. Before you look at any question, you just want to immediately get all of the sort of totals for this. So that means the row totals, column totals, and the table total. So let's go ahead and get those row totals first. So 11 plus 38 plus 17. We should see that we get 66 there, and 17... 19 and 18, looks like we get 54 there. And then 5, 12, and 26, looks like we get 43 there. Then the column totals, looks like we get 33 there, 38, 19, and 12. Looks like we get 69 there, and 17, 18, and 26. Looks like we get 61 there. And then we can make a table total, adding 66, 54, and 43. We should get 163. And of course, you can check if you add these three values, 33, 69, and 61, you also get 163. So that confirms that we did that correctly. All right, first thing that we wanted to know, the sample size. Well, as we talked about, that can be found as the table total here. So the sample size was n equals 163. So we had 163 subjects in this experiment, right? 66 received the Cheapo Comfort, 54 aspirin, 43 the placebo, and 33 of them felt like their pain was removed, 69 felt it was reduced, and 61 did nothing. And of course, all these values here are people who experienced this treatment and that sort of effect. All right, next thing that we wanted to do was we wanted to get the percentage who received Cheapo. Well, we know as a percentage, it was a percentage of the sample, so we're going to be dividing by that 163. I apologize for that. We'll take that 163, we'll go find the Cheapo group there. That looks like there were 66 of them. So to calculate this, all we need to do is do 66 over 163, and then we'll write that as a percentage. So 66 divided by 163, looks like we should get 40.5%. So 40.5% of all the people that we picked for this experiment ended up receiving the Cheapo treatment. All right. We've got another one that we wanted to sort of calculate as a percentage. We wanted the percentage who received placebo and I believe said removed. So we wanted to calculate the percentage of people who took the placebo treatment and also ended up saying that their pain was removed entirely. So since it says that and, right, that requires that they had both of these traits. That means we'll be looking right here on the inside of the table for those 5 people who did take the placebo and saw that said that their pain was removed. So we'll do that as a calculation again. So that'll be 5 over 163. 5 divided by 163 should give us approximately, 3.1%. So only a tiny percentage of our sample both took the placebo and felt that their pain was removed entirely. Only 3.1% of our sample had that experience. All right, now D says that we want to do the conditional distribution based on treatment. So this is telling you, right, in the language of this, that treatment is being used as the explanatory, which makes sense, right? We would expect that the type of drug that these people take might help explain their sort of effect or experience. But the question itself is telling us to do this based on treatment. Now, the treatments were in the different rows, so we are going to do this by divide by the row totals. Why are we choosing row totals? Because the rows held each of the individual treatments. If the treatments had been up here in the sort of columns, then we'd be dividing by column totals, but treatments were here in the rows. So let's rebuild our table. So we'll sort of abbreviate a little bit. There's CC, aspirin, and placebo. And then I guess that we'll just say remove, reduce, and nothing, just to abbreviate a little bit. So we'll rebuild our table. Okay. And remember, we're going to be dividing by these row totals. So first value here is going to be that 11 divided by that 66. So 11 divided by 66 looks like we should get 16.7%. So what does that 16.7% mean? That means that 16.7% of the people who took that cheapo comfort felt like their pain was removed. So 16.7% of the people who took cheapo comfort felt that their pain was removed. Next one would be 38 divided by 66. That would be 0.6%, excuse me. 0.6%. So that means 57.6% of people who took the cheapo comfort felt their pain was reduced. And then 17 divided by 66 looks like we should get 25.8%. So what that tells us is that 25.8% of people who took the cheapo comfort medicine felt that it did nothing. All right, now we'll be moving into the next row. So everything will be divided by that 54 there. So let's go ahead and do that. 17 divided by 54 looks like we should get 31.5%. Then 19 divided by 54 should be 35.2%. And then finally, 18 divided by 54 should be 33.3%. So that tells us that 31.5% of people who took aspirin felt like their pain was removed. 35.2% who took aspirin felt like it was reduced. And 33.3% of people who took aspirin felt that it did nothing. All right. Finally, we've got the placebo, so now we'll be dividing everything by 43. So divide by 43, we should get 11.6%. Then 12 divided by 43 should be 27.9%. And then finally, 26 divided by 43 looks like we should get 60.5%. So that tells us that 11.6% of people who took the placebo felt like their pain was removed. 27.9% of people who took the placebo felt like it was reduced, and a large majority, 60.5% of people who took the placebo felt that it did nothing. All right, so that is our conditional distribution. Now let's use it. So we wanted to say, does that cheapo comfort work? Well, how would we determine if it works? Well, to determine that if it works, what we want to do is we want to compare that cheapo comfort against the placebo, right? You want to sort of treat the placebo as the control and say, did cheapo do a better job than that placebo? So let's look at the information that we have here, right? If we look in the category of remove, which remember is the ideal thing to have happen, Cheapo Comfort did that for 16.7%, where the placebo only did that for about 11.6%. That is good for Cheapo because it had a higher percentage of people who said that it was removed. For reduced, which is also a good outcome, it was 57.6 versus 27.9. Also good for Cheapo. And in the one sort of bad effect, doing nothing, notice that Cheapo, 25.8, was much lower than the placebo, 60.5. So that all indicates that Cheapo Comfort does work, right? CC does seem to work since it had higher rates, or higher percents, higher rates of remove, reduce, and a lower rate of nothing compared to the placebo. Apologize for my dog in the background, not happy apparently with the placebo treatment or all this talk about the conditional. Sorry about that. All right, so we can see that Cheapo Comfort seems to work because in terms of the two good outcomes, removing and reducing, it did a better job than the placebo, and the sort of bad outcome of doing nothing, it had a lower rate of that. So all of that seems to indicate that the Cheapo Comfort is better than not doing anything at all, which of course is what the placebo is. All right, now let's talk about, is CC better than aspirin? Now, this is an interesting question because it actually, you could argue both ways. Let's think about if you were really pro Cheapo Comfort. For some reason, maybe you're the creator of it or you're the salesperson of it, you really have to argue for it. Well, if you compare Cheapo versus aspirin, you're not thrilled about this first thing here, right? Is 16.7% for removing is lower than aspirin. That means Cheapo doesn't seem to do as good of a job in terms of removing pain entirely. You are, though, a little excited about the reduced. It's 57.6% versus 35.2%. But you probably wouldn't want to call attention just to that, because if you said, oh, hey, we have a higher rate of reducing, aspirin would just simply say, well, we have a higher rate of removing, that's much better. Instead, if you were really pro Cheapo, what you'd probably want to call your attention to is the lower rate of doing nothing. That 25.8% is lower than 33.3%. That means for you, only about a quarter of people have no effect. But for aspirin, it's closer to a third of people, meaning Cheapo is better at least doing something. So we could write that argument out by saying Cheapo is better since the rate of nothing is lower compared to aspirin. Okay? Now, how would aspirin sort of respond to that? Well, aspirin, obviously, right, if somebody was concerned about this, would definitely want to point to this, right? We could argue that aspirin is better since the rate of remove, which is the best outcome, is higher compared to Cheapo. So the point here is that there's not necessarily really a right answer to, is this one better than the other? But what we want to call attention to is how you would justify if you were going to take a particular stand. Cheapo would want to argue that they're better because more people, a higher percentage of people, benefit from their product. It might not be a full benefit, it might not be a removal of the pain entirely, but it is at least something. Only 25 or 26% of people have experienced no benefit. Aspirin, on the other hand, it's close to a third of the people experience no benefit. Aspirin, on the other hand, could argue that it's better than this sort of Cheapo Comfort because the best possible outcome, which is removing, is going to be 31.5 versus only 16.7. So to summarize, we could say that Cheapo might be sort of better in a pinch because it at least does something, while aspirin seems to be better for those it really works on, because those people that it really works on, they are going to get that full benefit of that sort of removal of their pain. So that's just a quick thing to sort of think about in terms of how to use the conditional distribution to make some decisions. In our next video, we'll take a look at sort of another example of that, of sort of seeing how we can use that conditional distribution that we build to continue to sort of interpret, make decisions in a situation.